Hello, I'm Edward Gomez. I'm the Education Director for Las Cumbres Observatory. One of the very important parts of my role is creating online applications and websites for astronomy education. These include Spacebook, an online textbook of astronomy, Agent Exoplanet, an interactive pedagogical website for learning about photometry and exoplanets, Serol's Cosmic Explorers, a suite of interactive web resources using robotic telescopes, and the award-winning Star in a Box, an interactive app for learning all about the life cycle of stars. Now, when you're creating interactive and online web apps, and I'm going to use the phrase or the word app in this talk, but I'm using this to mean an online resource. So it could be a website content, a video, an interactive website, or some sort of virtual or augmented reality app. So when you're creating your app, you'll be tempted to let the science or even the technology drive the direction that you take. From experience, this is a bad idea. It's fine to let these be the inspiration, but not the driving force behind the app, because then you end up with something which won't achieve your educational goals and could end up being too complex for the audience. You also might have pressure from your funding agency or your home institution, which are sponsoring this work. So that has to be a factor, because obviously they're paying the bills, but don't let it be the driving force behind what you do. So when I start a new project, there are 4 things that I consider. Goals first, who is your audience, time is precious, and think technology. Goals first, decide what you want to do and why you want to do it. For a small app, this should be only 2 or 3 goals. Keep them simple, keep them generic, and refer to them when you're going through your design phase. You want a large portion, if not all of your audience, to achieve your goals. Good goals are, after you've finished using the app, the audience will know more about the life of a star. A bad example of a goal is the audience will be able to derive Newton's laws of motion. One's quite generic and general, and one's highly specific. It doesn't mean that you can't differentiate ability in your audience through the use of your app, just not in your goals themselves. And remember, refer back to your goals when you're designing the app, because that'll really influence what you do, and make sure that you're really you really focus on what's important. Number 2, who is the audience? Remember, you are not the audience. What inspires you probably won't inspire your audience, depending on what your audience is, but they almost certainly won't inspire your audience. And even if your audience is very similar to you, or you think that they are, they probably won't be at the level that they'll be using this app. So think very carefully about who the audience is, because that's going to impact how you design your app. Saying my audience is everybody is not very good. Yes, you might have aspects of your app which are applicable to a general audience and a general public or families, but you should maybe think about whether it's a school audience or a high school audience, or high school students, or high school students and teachers. It's okay to have your audience be multiple groups, like teachers and students. But remember that you've always got to tailor your app towards that audience. Okay, and that's something else that you need to refer to again when you're in your design phase. Time is precious, particularly if you're an educator or like a teacher. So don't make the audience do tedious things without good reason. Sometimes the tedious thing is actually a good thing to do. Because when you repeat things, they become more automatic, and then you can think about other things. But don't make them do tedious things. So don't make them read through a lot of documentation if they don't need to. Or if you do need them to read through a lot of documentation, maybe your app is too complex, and actually once they've read through the documentation, they won't understand what they need to do to actually achieve the goal. So think very carefully about that. They will get bored. They'll get bored even if your app is the most exciting thing. So you want them to get bored as late in the process as possible. Think technology. Make your app as accessible as possible via the technology that's available. Be careful of using bleeding edge technology as well, because bleeding edge technology is really only suitable for bleeding edge hardware or the latest in hardware and software. You want something that's going to be really stable on a variety of systems, whether it's a mobile device or a desktop device. So you really want this to be stable. An old browser or an old mobile phone should be able to cope with your app. Particularly if you think of that some of your audience is not based in your city. Some of your audience might be in a rural community, or it might be in the developing world. If you are going to hire a developer to do the development of your app, then think very carefully about what's going to happen when the developer's finished and the funding has run out. Are you just going to have your app as a snapshot and it'll just stay there with no features, and if there's a problem with it, then you're stuck? Or if you can work with the developer and understand how the system works, then you can learn on the job and you can be the maintainer for free. It depends how much you're invested in this project. Almost all of the interactive apps that I've been a part of, I am now the maintainer of, because I'm really invested in them. I see the educational benefit from them. I really am very proud of them. So either I've learned the technology behind them, or it's something that I already know about. And so I can, when there's a bug report, I can help with the maintenance of that. Or find people who can. The open source community is a really fantastic community, but it can be difficult to find people who are willing to help. And depending on your software solution, then you might be able to tap into those communities. So how does this work in practice? So I'm going to give you 2 case studies for apps that have used this methodology. And you can also go to my colleague Alice Hopkinson's talk on Serol's Cosmic Explorers, which is in the remote observing session. And that'll give you a complete picture of that project, which involves remote observing as well. The first example I'll give you is astroEDU. This is a platform for improving astronomy education resources through peer review. A major aspect of this project is the website where the activities are published. So goals first. The goal is to improve astronomy education activities through peer review. Concise, not overly prescriptive. And the reason for that is that we saw that there were similar projects in other disciplines which did sort of either editorial review or full peer review for educational resources, but not in astronomy. So we wanted to provide that for astronomy. And we also wanted a place that people could point to their resources and their activities, and for them to have a life after an institution website has gone down. Who is the audience? The audience for astroEDU are educators. They could be teachers, university lecturers, homeschooling parents, museum staff. This is quite a specific audience, but it's also quite a broad audience. So to cope with that, we allow the content on the astroEDU website to be filtered so it's more appropriate for different educators. Time is precious. This was a big consideration when we were planning astroEDU. We wanted to save people time, and in providing high quality astronomy activities in a place where they could find them and know that they'd been through peer review, so that they were of the highest quality. But we want educators to be able to remix the activities too. So we don't want to just provide them with something that they can print and they have to write on. So we provide, as well as a high quality PDF, which has graphic design on it, we provide the bare content, the images and the text. We provide the bare content, the images and the text, as a Word and as a rich text format document, so that the educators can then remix it themselves and add their own different angle on it, because each curriculum around the world is different. Think technology. The astroEDU website is where all the activities that have been through the peer review process are published. This was created by a developer, thanks to initial support from the Office of Astronomy for Development and Leiden University. Pedro Russo then had, who was one of the co-founders along with myself, then had a Horizon 2020 grant, which was then used for some extra development. However, in the last few years, we've had no funding for astroEDU. Fortunately, the platform, the website, was written in the web framework Django, which is itself written in Python, which is something I know a lot about. So I could take on the reins of being the maintainer for that. And we've had some feature requests, some bug requests, and bug reports, and I've been able to fix those myself in the last few years. Now that's really important because otherwise astroEDU would have been a bit broken in some ways, and it would have been yet another project which had just run out of funding. So you can see the importance of that aspect. The second project I want to tell you about is Star in a Box. It's an interactive app for exploring the life cycle of stars, and it's available in 8 languages. Back in 2014, it won an award from Scientix. So our goals: we wanted teachers to have confidence in teaching the life cycle of stars. We realized that many physics teachers are not physicists, and even fewer of them are astronomers. So the life cycle of stars is potentially quite an alien concept to them. And we looked in textbooks and we realized that the quality of the description in textbooks was a little bit misleading. So we wanted to provide something that was interactive, so you could play around with different sizes of star, but fit it in with the curriculum and help teachers in that way. So there you are, that's the second point. Who is the audience? The audience are high school students and teachers. Time is precious. Again, we wanted to save teachers time by creating this app, but we also wanted to make sure that by using this app, we didn't introduce other factors which would be frustrating to them. We wanted them to just get on with the app. So we made the resource a self-contained demo, and we created lesson plans which assist its use in the classroom. So you don't have to use the lesson plans, but you can. It has an intuitive interface, so that facilitates the learning through experimentation. Anybody can go to the website and play around with it and learn more about the life cycle of stars. But in particular, we aimed it at high school students. So the qualification you do at 16 and 18, GCSEs and A-levels in the UK. Think technology. Star in a Box is written in JavaScript and HTML. No bells and no whistles, no fancy JavaScript libraries like React. It'll work on any web browser, desktop or mobile, and it has a very small data footprint. So it actually works very nicely on a tablet. We've paid attention to all the click gestures. Although I'm the creator of the project, many people worked on it in the last 10 years. Colleagues of mine at Las Cumbres Observatory, interns we've had, and I remain the maintainer of the project. But it's an open source project. It's available on GitHub, and I've had several people contact me with language files. These are just JSON objects, which I can just drop into Star in a Box, and we have Star in a Box in a new language. This was done for the Arabic and the Italian versions, which is phenomenal that the community enjoyed this app so much that they wanted to share it in their own language. So I hope you find my tips useful when creating your own online resources. If you have any questions about any of this, I'm more than happy to answer any of them, and I'll leave my details up on the screen now on how you can contact me.